A triple integral extends the idea of volume from something flat into something solid. Instead of finding area over a flat region, we now find a total amount over a three-dimensional region in space. Let's set up a worked example. We want to find the volume of a solid sitting above a triangular base and below a sloped roof. First, here is the two-dimensional view of the base. It is a flat triangle in the xy plane, with x running from 0 to 1, and for each xy running from 0 up to x. Now watch this same triangle grow upward into 3 dimensions. The solid rises from z equals 0 up to a slanted top surface where z equals x plus y. To find the volume of this solid, we build a triple integral. In words, we integrate over z first, then over y, then over x, working from the inside out. The limits for x come first. X goes from 0 to 1. The limits for y come next. For each x, y goes from 0 up to x. The limits for z come last. For each x and y, z goes from 0 up to the quantity x plus y. Now we write this as one triple integral. Integral from x equals 0 to 1 of integral from y equals 0 to x of integral from z equals 0 to the quantity x plus y of dz, dy, dx. We integrate the innermost variable first, which is z. Integral of dz from 0 to the quantity x plus y equals x plus y. We substitute this result back into the integral, which removes the z integral completely. Now we have integral from x equals 0 to 1 of integral from y equals 0 to x of the quantity x plus y dy dx. Next we integrate over y, treating x as a constant. Integral of the quantity x plus y dy equals x times y plus 1/2 times y squared. We evaluate this from y equals 0 to y equals x. This gives x times x plus 1/2 times x squared, which simplifies to 3/2 times x squared. We substitute this back, leaving only the x integral. Now we have integral from x equals 0 to 1 of 3/2 times x squared dx. We integrate this last piece over x. Integral of 3/2 times x squared dx equals 1/2 times x cubed. We evaluate this from x equals 0 to x equals 1. The quantity 1/2 times x cubed evaluated from 0 to 1 equals 1/2 minus 0, which equals 1/2. So the volume of this solid equals 1/2. Check step. The answer is a positive number, which makes sense because volume can never be negative. The value 1/2 is also less than the volume of the full unit cube that contains this solid, which makes sense since our solid only fills part of that cube. This confirms our answer of 1/2 is correct.